I have discussed the some elastic constant. The first one is Young's modulus, which is defined as the ratio of normal stress to the longitudinal strain, and the shear modulus is shear stress to the shear strain. Bulk modulus is the either you can consider as a average stress or the hydrostatic stress to the volumetric strain. Poisson's ratio is the ratio of lateral strain to the longitudinal. So lateral strain is nothing but the change in dimension in the perpendicular to the direction of applied load, that is delta D divided by original diameter. Similarly, for longitudinal means whatever the strain which you are getting in the direction of applied load. Okay, so these are the four elastic constants, but there is a relation between these elastic constants. So let me write those relation. Then we will move to the problem. So the first one is E is equal to 2G 1 plus mu. Second is E is equal to 3K 1 minus 2 mu. Okay, so this is the basically relation between these elastic constant Eg and mu. Now the question which was asked in the 2015, what is the question? A rod is subjected to uniaxial load within linear elastic limit. Okay, within linear elastic limit means, so because you already know the stress strain diagram, so this is basically the stress strain diagram for the mild steel. So there are some point which is nothing but the proportional limit, elastic limit, yield point, and there is a ultimate point and the fracture point. So within the linear elastic limit, a rod is subjected to uniaxial load when change in the stress. So what is the question given? Change in the stress value is 200 megapascal. Change in the strain is, that means change in strain is given as 0.001. Change in strain is given, change in stress is given. Can you calculate the value of Young's modulus? The Young's modulus is change in stress by strain or the stress by strain. Okay. So what is the change in stress? 200. This is 0.001. So you can write 200 into 10 to the power of 3 megapascal, or you can write 200 gigapascal. 200 gigapascal. Okay. So I have written this 10 to the power of 3 megapascal in terms of gigapascal. Now, what is the question? If the Poisson's ratio, that means mu value is given as 0.3. Mu value is given as 0.3. So, can you calculate the modulus of rigidity? Modulus of rigidity means shear modulus. G value you have to calculate. E you already calculated at 200 gigapascal. 200 gigapascal. So, can you calculate the G value? Yes. E is equal to 2G 1 plus mu. This is the relation between elastic constant. So E is given as 200. This is 2. G value you have to calculate 1 plus 0.3. So what is the value of G? 100 divided by 1.3, which is nothing but approximately, once you will solve this, you will get the 77 point something. That means 77.77. So 77, or you will get a 76.92, which is approximately 77 gigapascal. Okay. So the correct answer for this question is G is equal to 77 gigapascal. So what you have done, you have calculated the Young's modulus and you know the relation between the E and G. So E is equal to 2G 1 plus mu. And the another relation for the elastic constant K is 3K 1 minus 2 mu. Okay. Now, then you can calculate the unknown. Sometimes they will give you the value of G. You can calculate the E value or the K value by using those two expressions. So one more question is there. The Poisson's ratio of material is given. You have to calculate the ratio of modulus of rigidity to the Young's modulus. Okay, just try to use those two relation. Let me take in the next slide and tell me what answer you are getting. And please read the question carefully. There is a chances for doing the mistake. Once you will get the answer, please let me know, then I will explain. So Poisson's ratio is given. You have to write down the ratio of modulus of rigidity to the Young's modulus. You got the answer, Jagan and Josie. Poisson's ratio is given as 0.4. Okay, you have to find the ratio of modulus of rigidity, nothing but G by E.
1 by 2.8.
1 by 2.8. Very good. That means approximately 0.357. Okay.
Yes.
So why they have framed this question? I will explain you. You have to calculate the ratio of G by E. Okay. But you know the relation between E and G. So most of the time the student will do the mistake. E is equal to 2G 1 plus mu. They know this particular relation. So mu value is 0.4, which is nothing but 1.4 into 2 is 2.8, and they will write E by G ratio is 2.8, means they will write down the final answer 2.8. You will get the 0 marks. Again, read the question. They were asking modulus of rigidity to the Young's modulus, not E by G. They want what is the ratio of G by E. So 1 by 2.8. Once you will calculate, you will get 0.357. And this is the correct answer. Okay. So in every question, I'm telling you, before answering the final, then you have to write down the you have to read the question carefully. Now this is the one more question, gate 2014, based on whatever I have discussed. What is the question? A metallic rod of 500 length and 50 diameter, okay, experience an increase in length by 0.5 What means? There is a metallic rod, you are applying some particular load. Because of that load, the length is given as 500 and the diameter is 50 Once you are applying the 100 kilonewton load, what will happen? The length is increased by 0.5 That means initially it is 50 Now the length will become 50.5 Okay, sorry, 500.5 Then there is a reduction in diameter. Yeah, same thing I have told you. No, there is a longitudinal strain and the lateral strain. Now what you have to calculate the ratio, the Poisson's ratio. You already know the Poisson's ratio is nothing but the the lateral strain to the longitudinal strain. What is the lateral strain? Change in diameter to the original diameter. Longitudinal strain is change in length by original length. Okay. So this parameter is given, original length is given, D is also given, this is also given. Just put in this formula, you will get the answer. This is the rod. You have subjected some particular load. Because of that, the rod length is increased from L to LF and the diameter is decreased from D to DF. DF means final diameter. F is corresponding to the final diameter. And the initial length is nothing but the original length or the initial length. Just 1 second. The initial length is nothing but the L naught and D naught will be the original diameter. This is the original length. So change in length means the final length minus initial length, original length. Okay. So change in length they have given directly. How much increase in the length? 0.5 Do it fast. Everything is given. This is given. This is given. D and L value is also given. So what you have to calculate? You have to calculate Poisson's ratio. Once you know, you got the result, please let me know. So Janesh is telling the one. Can you check your calculation, Janesh? One is not the correct answer. I think you have done some mistake. Very simple. The change in diameter. First of all, this is the change in diameter. Now they have given reduction in diameter. Reduction in diameter means the diameter is decreasing. So can I write delta D value is given as minus of 0.015 mm, 0.15 mm. Reduction in diameter is given. Original diameter is, what is the original diameter? Yes, original diameter is given as 50 mm. In change, increase in the length. Increase in length means delta L value is given as 0.5. And what is the original length? Original length is 500 mm. Okay. So what is this delta D minus 0.015? It will become positive. Divided by 50. Divided by 0.5. Divided by 500. Okay. Now if you solve, this will become 10. This will become 10. And this is nothing but, what is the original diameter? 50 mm. What you have to calculate? Poisson's ratio you have to calculate. Once you will solve, you will get the answer as 0.3 because this value is 0.03 and this 10 will come into the numerator and it will become 0.3 is the Poisson's ratio. Okay. 0.03 into 10 is nothing but 0.3. The one is not correct answer. 0.3 is the correct one. Increase in the diameter, reduction in the diameter they have given. Original diameter also they have given. Original length as well as change in length they have given. Only you have to put in that formula, you will get the answer. I hope everyone is getting the same answer. Is it okay, Ganesh?
Yes, sir.
Oh. Now the next thing is, okay, so this is the question. I have given you the two important relation. So from there you can use a 200 into 100 into 50 steel block. What is the steel block? Steel block will be like this. Okay, this is 200, this is 100, and this is 50. One block is there which is subjected to hydrostatic pressure. I have told you, the hydrostatic pressure means the stress developed in all the three dimension is same. So hydrostatic pressure or the stress value is given, which is nothing but 15 megapascal. Young's modulus is given as 200. Poisson's ratio is 0.3. What you have to calculate? Volume of block. That means change in volume of block you have to calculate. How you will do? You already know the ratio, the expression for volumetric strain, the Young bulk modulus, the hydrostatic stress divided by the volumetric strain. What is volumetric strain? That means volumetric strain is change in volume to the original volume. Because the strain means change in, let us suppose, longitudinal strain. Longitudinal strain means change in length by original length. Similarly, volumetric means total change in volume divided by original volume. And what you have to calculate? Change in volume. So can I write from this one? Change in volume into sigma into V divided by the K. Okay, what I have done? I just kept this particular value here. So delta V by V. So delta V by V is equal to sigma by K. Then V I have multiplied here. Now you have to calculate this value. The hydrostatic stress is given. Volume is also you can calculate. But how you will calculate K value? Because E and mu is given. And the two important relation between the elastic constant. The first one which I have discussed previously, E is equal to 2G 1 plus mu and E is equal to 3K 1 minus 2 mu. Okay, so these are the two relation between the elastic constant. E is the Young's modulus, G is the shear modulus, mu is the Poisson's ratio. Now, E and mu value is given. So what you have to calculate? You have to calculate the K value. Once you know the K value, stress value is given, volume you can calculate, your problem is solved. That means, can I write the change in volume is nothing but sigma by K. I can write as a K is nothing but E by 3 into 1 minus 2 mu. 1 minus 2 mu. 1 minus 2 mu. So I will put here E into 3 into 1 minus 2 mu into volume is the final one. What I have done, see, stress is given, volume you can easily calculate, just multiply this. How you will calculate K value? K value is nothing but E divided by this 3 into 1 minus 2 mu. Everything is given. Once you will put in this one, you will get the result. Okay, so the change in volume is nothing but 3 into, what is this stress? 15. What is the Young's modulus? Again, see, here it is given in gigapascal, the stress value is megapascal. So I will convert into megapascal only. 200 into 10 to the power of 3 megapascal. Because 1 gigapascal is nothing but 10 to the power of 3 megapascal. So you know the 10 to the power of 3 megapascal. That's why I have kept here. This is in megapascal. Okay, so Poisson's ratio is also given 1 minus 2 into 0.3 into volume. What is volume? 200 into 100 into 50. All are in mm, no problem. Okay. So can you please tell me now how much volume you are getting? Just multiply this value. If I will simplify, let's take this one here. Change in volume is nothing but 1 minus 2 into 10 to the 0.3 is 0.6, 0.4. So 3 into 0.4, this value is 0.4 into 3 is 1.2. So 1.2 into 15 divided by 200 into 10 to the power of 3. So can I write this is 200 into 5 into 10 to the power of 3? Because this is 5, 10 to the power of 3. Why I have written? Because I can cancel this stuff. What is this value then? This is nothing but change in volume. Once you will calculate, this value is 90 millimeter cube. 90 millimeter cube. So what is the correct answer for this question? The correct answer for this question is B. Okay. So the bulk modulus relation you have to use the stress divided by volumetric strain. Volumetric strain, you know that change in volume by original volume. The change in volume you have to calculate. The stress value is given. Bulk modulus also you can calculate by using this relation. Okay. You have to remember this relation because sometimes they are giving the mu and E, you can calculate G. So once you know the K value, so the stress value is given, volume is given, you can calculate the change in volume. So this is the correct answer for this question. Okay. Now the next one is, okay, so can you please try to solve this problem? Same problem, same concept you have to use. An elastic isotropic body, this is a one block is given, is subjected to hydrostatic state of stress. I have told you what do you mean by hydrostatic? Sigma x, sigma y, sigma z both are same. For no change in the volume of, for there is no change in volume. You know the change in volume formula which I have discussed here. Okay, just make it 0 because they told change in volume will be 0. What should be the Poisson's ratio? So mu value you have to calculate. Okay, what you will do? First you write down the K is nothing but volumetric hydrostatic stress divided by volumetric strain. Volumetric strain, you know that change in volume by original volume. This is the hydrostatic stress. Okay, so if I will write down the same expression here, which is nothing but 3 sigma by E. This is nothing but 3 sigma by E 1 minus 2 mu. Okay, this is sigma here. Volumetric strain, I have kept here K value. What is the K value? E divided by 1 minus 2 mu. Same thing which I have discussed in this one. K is nothing but E divided by 3 into 1 minus 2 mu. So if you put this one here, what you will get? If you put this one here, K value is E 3, 1 minus 2 mu. So same thing I have written. 3 into 1 minus 2 mu, sigma V is nothing but this one. So if you want, you can calculate change in volume. 3 sigma E 1 minus 2 mu into V. Now the question it is given when there is no change in volume. No change in volume means the volume change in volume will become 0. Just equate to 0 and tell me what is the mu value you are getting. Just equate delta value is 0. Then you have to calculate the Poisson's ratio. These all are constant only. Okay. Very simple. This is the equation you have to solve, which is equal to 0. That means mu value you will get from here.
0.5, sir.
Very 0.5 is the correct answer. Very simple. 1 minus 2 mu into 3 sigma by E into volume is equal to 0. Okay, so sigma stress is given. Okay, volume is also, there is some certain volume. E is the constant. These all are constant only. So this should be equal to 0. 1 minus 2 mu is equal to 0. So mu is equal to 0.5. Now, one more important note point I want to discuss from this question. For there is no change in volume, you are getting Poisson's ratio is 0.5. Okay, Janesh also have given the correct answer. But if the question is mentioned for incompressible material or for incompressible material, what will be the Poisson's ratio? In that case also, the Poisson's ratio is 0.5. What do you mean by incompressible? Which cannot be compressed. Which cannot be compressed means change in volume is 0. That means whenever they have mentioned for incompressible condition also, in that case also the Poisson's ratio is, for incompressible case, Poisson's ratio value is 0.5. Because incompressible means you cannot compress. That means there is no change in volume. There is no change in volume means again this value will be 0. That means mu value you will get as a 0.5. Okay. So what is the correct answer for this question? See. So these type of question they are framing. Now the next concept which I'm going to discuss, which is nothing but the question based on thermal stress. Question based on thermal stress.
Excuse me, sir.
Tell me.
So in this question, sir, here of this hydrostatic stress, sir, if this elastic isotropic body is in hydrostatic stress, sir, then the direction of the stress acting should be towards that cube, sir, not to the outer side.
It doesn't matter. The condition for hydrostatic means the stress value should be same. It may be a compressive, it may be a tensile. Sigma x, sigma y, sigma z should be equal. It may be a compressive also, it may be a tensile, but the value should be same. So when you are dipping on the water, then in that case you can see, you can observe the block is in the compression, but you can apply the tensile force also, no? The condition for hydrostatic means when the stress value in all the three direction will be same.
Sir,
Same
I
I have
can't hear you properly.
Is my voice is clear, Jagan and Janesh?
Yes, sir.
As you can check your internet, I think from my side it's fine. What I'm telling, for hydrostatic stress, sigma x, sigma y, sigma z should be same. It may be a tensile, it may be a compressive. Even if you consider compressive also, if they have given this one also, you will get the same answer because this doesn't play any role. Mu value you will get as a 0.5. But hydrostatic means there is the stress value in sigma x, sigma y, sigma z will be same. It may be a tensile, it may be a compressive. Okay.
Okay, sir.
Okay, now one more important concept that is thermal stress. So before come to this particular problem, thermal stress problem, I just want to give a quick recap of the thermal stresses, how you will calculate the thermal stress value. Quickly, I will revise. So what is the meaning of thermal stress means? Whenever any object which is subjected to a temperature variation. Okay, whenever any object, when you are subjecting a temperature variation, then what will happen? So let us suppose you just take one block here. Okay, then you are increasing the temperature. Raj, please mute yourself. Then you are increasing the temperature. Then what will happen? When you are increasing the temperature means, that means the dimensions are increasing. The dimensions of this block will increase. First, if you are decreasing the temperature, so this block will be in the contraction. That means when you are increasing the temperature, but this portion, or let us suppose this portion is fixed one, what will happen? because of the temperature variation, this will try to expand. Yes or no? Because of the temperature increase, this will try to expand, but because of the fixed support, there will be some reaction. Then that means there is something which is resisting the expansion of this bar or expansion of this cube. So in that case, the stress will develop. So there are the two important conditions for developing the thermal stress. The first condition is there should be a temperature variation. There should be a temperature variation. Second thing is whatever the thermal expansion or contraction means it can expand also, it can contract also, depending upon either you are increasing the temperature or decreasing the temperature. Due to the above temperature gradient, should be restricted either completely or partially. If these two conditions are there, then we can say that the thermal stress will develop. First of all, there is a temperature variation. That means either you are increasing the temperature or decreasing the temperature. And if you are increasing or decreasing temperature, there should be some restriction from the supports or some other means. That means either it should be a completely restricted or some amount of elongation you are giving. So there will be the two cases possible. The first case I'm going to discuss, let us suppose this is completely restricted. Let us suppose this is the rod which is restricted from both the sides and you are increasing the temperature. Let us suppose their coefficient of thermal expansion is alpha, Young's modulus is E, and the diameter I am just considering as a D. Initial length is L. Now what I am doing, I am increasing the temperature by delta T degrees centigrade. What will happen? This rod will try to expand like this when there is no support, but because of the support, there will be some resisting force. When there is a resisting force, you know that what is the stress? Resisting force per unit area. Resisting force per unit area. So if there is any resisting force, then the thermal stress will develop. Okay. So for example, this support is providing reaction, let us suppose R. Then how you will calculate the total change in length? Can I write the total change in length is because of thermal or temperature variation or the axial deformation? Axial deformation means this R is also trying to compress this member, and because of the temperature variation, it will expand. So this axial deformation and thermal deformation will be equal to 0. Why? Because these both ends are fixed. What is happening actually, when you are increasing the temperature, this will try to expand like this. Okay, but because of the support, there will be a reaction. That means there is an axial deformation. You know the axial deformation formula, PL by AE, if P load is acting. So here R is acting, that means RL by AE. So thermal deformation means, what is the thermal deformation? Thermal deformation is nothing but alpha into delta T into L. Okay, so if it is a length L, delta T is the temperature difference, alpha is the coefficient of thermal expansion. This will be given in the question, which material you are using. So alpha value is different for different material. For example, if it is a steel, that will be 12 into 10 to the power of -6. So this will be given in the question. How much you are increasing the temperature, that is also given in the question. And what is the length, that will also given in the question. But you want to calculate the thermal stress. For that, you need what is the R value. Once you know the reaction force, if you divide with area of this bar, your problem is solved. That I am going to do. So the thermal deformation is alpha into delta T into L. What is the axial deformation of this bar? Axial deformation of this bar is minus into RL divided by AE is equal to 0. Why this minus? Because it is trying to compress this bar. Because of the temperature variation, it is increasing, but because of this R, it is decreasing. And that's why you are getting as a 0, because both end is fixed. You can't increase this length because of the fixed end. So from here, can I calculate the R value? Yes. What is the R value? Alpha delta T E into A. Alpha delta T E into A or A into E, E into A. This is the reaction which is coming out to be compressive. Okay. Now, if I want to calculate the stress, stress is nothing but the resisting force, that is R reaction divided by area. So alpha delta T into A is nothing but the thermal stress. Very, very important relation. Okay. I can write simply this relation and directly I jump to the formula. But I thought it's better to recap. Otherwise, you will ask, sir, I didn't understood. So alpha is the coefficient of thermal expansion, delta T is the change in temperature, E is the Young's modulus. You got the thermal stress value, this one. You got the thermal stress value, this one. Now, this is the first case. So the thermal stress here, if you see, that will be the compressive. Why this is compressive? Because you are increasing the temperature. Increasing the temperature, the reaction value is a compressive. If the reaction is compressive, the stress value is also compressive because you are dividing the area. So you have to remember, please, this relation, thermal stress is alpha delta T into E. Okay. Now, the second thing, what I'm doing, I'm just giving some amount of expansion. Okay, it can expand little amount. I'm not fixing this end. So let us suppose, just 1 second. Case number two. Case number two, the partially restricted expansion in one direction. Partially restricted expansion in one direction. So, because I have told you there should be a temperature variation, the thermal expansion, whatever the expansion and contraction is going on, due to the temperature variation, above temperature variation means which we are increasing, that should be either completely restricted or partially. So I have discussed about the complete, that means from both the side it is restricted. Now I am just discussing the second case when it is partially restricted. Partially restricted in one direction. Then how you will solve? Now just see here. This is the rod. This much amount of elongation, is allowed. That means when you increase the temperature of this particular body, it will try to expand like this. Okay, depending upon alpha delta T value. It will try to expand like this, like this, like this. But because of this support, there will be reaction. So it will expand till here only. That means in this case, I'm only allowing the delta value, the deformation value is lambda. Initially, I have assumed there is no deformation 0. Now I will write lambda here because this much amount of elongation is allowed. Okay. So the total deformation, can I write, is equal to thermal deformation plus axial deformation. Same thing, thermal deformation and the axial deformation. Now instead of 0, what you will keep? Lambda. Lambda is how much amount of elongation or whatever it is you are allowing. Okay. What is thermal deformation? Very simple. Alpha delta T into L. So here axial deformation, that means once it will reaches here, then this support will provide some reaction. So in this case, I'm using the R1 value. In this case, just to differentiate this R and R1, because here R1, R I have used for the first case. So in this case, I'm using R1 value. So this reaction R1, can I write R1 into L divided by AE is equal to lambda. Can I calculate the R1 value from here? Or directly you can calculate the stress. So R1 into L divided by AE is equal to alpha delta TL minus lambda. Okay, so what is the R1 value? Alpha delta TL minus lambda divided by L into E. So R1 by E. This is the resisting force. This is the area. Can I write this is a thermal stress? Thermal stress. Alpha delta TL minus lambda L into E. So please remember these two cases for solving the problem. Now, if you want to verify the first case, in the first case, what you have assumed, the lambda value is 0. Just put in this one. Lambda is 0. This is 0. LL will cancel out. The alpha delta T into E. Again, you will get the same expression. That means this expression, if you have remember, you can solve the problem based on the first case as well as second case. First case means there is no expansion is allowed, lambda value is 0. Lambda 0 means alpha delta T into E. And the second case, if you are allowing some expansion, then alpha delta T L minus lambda divided by L into E. Okay, so please remember this relation. One more case, very important, I will make as a 5-star. Okay, the case is for free expansion. For free expansion. For free expansion, what will be the thermal stress value? This is very, very important. They are giving the question very lengthy, but they mention as a free expansion. Whenever you see the free expansion case, always the thermal stress value is 0. What it means, for example, if you take this as a bar, just increase the temperature. Okay, what will happen? If you are increasing 50 degrees centigrade, it will expand like this. If you are increasing 100 degrees centigrade, it will expand like this. That means there is no resisting force. If there is no resisting force, what is the thermal stress? 0, because thermal stress value will come when there is a resisting force. So always remember this first, this particular case. I will discuss some problem also. Then you will appreciate what is the free expansion. Free expansion means you are allowing that complete rod freely expand. There is no resisting force. There is no resisting force means the stress value will be 0. Okay, so I have discussed the 3 cases. So now you can easily solve this problem. So let me write down the 3 cases here. First one formula you got as a thermal stress is alpha delta T into E. Second one is thermal stress is alpha delta T L minus lambda divided by L into E. And the thermal stress value will be 0 in free expansion. In free expansion. Okay. Now try to solve this problem. A steel rod, read the question. The data is given already. Alpha value is given. Modulus of elasticity is given. And the length is also given. Everything is given. You have to calculate the stress value in the rod. Read the question and try to solve. Once you got the answer, please let me know. So you have to use the first relation because it is mentioned it is held between two rigid support. A rod is there. That means both the end is fixed. So completely restricted. Alpha value is given. Delta T is also given. E value is also given. Do it fast. Very simple. The steel rod of length is this 100 mm. Okay. Both end are fixed. It is given to rigid support. Heated by 20 degrees centigrade. That means delta T value is given as 20. Alpha value you are getting as it is given 15 into 10 to the power of minus 6. Modulus of elasticity is also given.
Sir, option
200.
C.
Option what? Which option? D.
C, sir. 60.
Okay, very good. Option C. Let me check. So 200 megapascal. Now, what you have to do, the thermal stress value is alpha into delta T into E. What is alpha value? Alpha value is 15 into 10 to the power of minus 6 into delta T value is 20. E value is 200 into 10 to the power of 3. Okay. So this value is 2 into 2, 4. And this 4 into 5 is 15 is 60. And this will be 10 to the power of 3, 10 to the power of minus 6, 10 to the power of 3. So this value is 60 megapascal. Yes. Megapascal, or you can write mega Newton per meter square. Okay, so the correct answer for this question is C. Okay, one more problem. This problem I have framed. Now I will discuss one more problem which was asked in the GATE 2007. Okay, so please make a note of this point. I have summarized all the relation. Just write down this, then I will move to the question. Next question you have to solve. Okay, fine. Now, can you solve this problem? A metal bar of length is given. Same problem. Data is different. Do it fast. I'm giving you only 30 seconds for solving this problem. Do it fast.
So 24 MPa.
24 MPa. What about Raj? Alpha value is given, delta T is given, E is also given.
Okay, sir. Actually, I was going to ask you regarding the recent questions. In recent question, how 60 is. Okay, sir. I got this, sir. We'll discuss the next question, sir. This thing I can.
Alpha value you know, delta T you know, E value is also given. Do it fast. Jagan has given the answer. Raj, please mute yourself. You can comment in the chat box also. Thermal stress you have to calculate alpha delta T into E. What is alpha value here? 12 into 10 to the power of minus 6. Delta T value is 10 degrees centigrade. E value is 2 into 10 to the power of 5. Okay. So this value is 20 into 12, that is 24 to 40. 10 to the power of minus 6 into 10 to the power of 5 is minus 1. Okay. Yes. 24 megapascal is the correct answer. Now, next question, if you see, again the same format. Now, if you see 2007, 2040, that means the importance of this topic, now you will realize. Okay, so the same question, you have to calculate the magnitude of longitudinal stress or the thermal stress. They clearly mention it is heated, temperature is given, thermal expansion is given, Young's modulus is given. Okay, so I'm expecting everyone, please give me the answer. You only have 1 minute. Do it fast.
$500 MP.
Jagan, let me check. What about Janice and Raj? Please do fast. 25 seconds or more. You got the result? What is the answer? Maybe Jagan has given the answer. Why you're taking this much time? More than two question I have discussed already. Thermal stress is alpha delta T into E. Everything is given in the question. Alpha value is given 250. Sorry, delta T is 250. What is the value of alpha? Alpha is given as 1 into 10 to the power of minus 5. What is the E value? E value is 200 gigapascal. Gigapascal means, but you have to answer in the megapascal. So you can convert into 10 to the power of 3 megapascal. So what is this value? 25 into 2 is 50. This is 10 to the power of 3. That means 10 to the power of 6 into 10 to the power of minus 5. Yes, 500 megapascal is the correct answer. How much time I have taken? 8 to 10 seconds. Only calculation you have to do, and this much time you are taking. Alpha value is given, delta T is given, E is given. Only you have to calculate. In the previous problem, I did the same thing. In the previous problem also, I have done the same thing.
Sir, in this question, they have asked longitudinal stress, sir. When longitudinal stress is asked, I need to use this formula, sir, this thermal stress formula.
Yes,
Because
longitudinal stress means longitudinal stress means this is the first of all rod which is immovable from this end. How the stress is developed in this longitudinal direction? Because of the thermal stress, no? Because if you are increasing the temperature, this rod will expand, but because of this immovable rigid wall, it will apply the reaction. So the thermal stress value and the longitudinal stress value is 500.
Okay, sir. Understood, sir.
This is the good question, I can say. For this question, I will explain, but I will give you 2 minutes. At least read the question and try to solve. Or if you know how to approach in this problem, just let me know. First, you read the question 2 minutes. After that, if you are able to solve this problem, tell me the final answer. Otherwise, I will explain. Because this question is based on the second type of case. Okay. What is the case first? When both the end are fixed one. What is the second case? When some amount of elongation is allowed. If you know the second case formula, no, you can solve this problem very easily. But apart from that, also, I will give you some insight of this question. Just use the second formula, you will get the answer. Read the question and try to solve. I'm giving you 2 minutes for solving this problem. Guys, please mute yourself.
uh, 240 MPA.
Okay. So one student have given the answer also 200 megapascal. Now see how you solve this problem. Okay, if you use my this formula, the second case formula, just one second. this one, you will get the answer. Okay. So if you use this particular formula also, you will get the answer, second case formula. But I just want to explain a little bit more for this question. What is this question? A circular metallic rod, this is the metallic rod, of length is 250 millimeter, okay, is placed between the two rigid immovable wall as shown in the figure. The rod is in the perfect contact with the wall on the left side, and there is a gap of 0.2 millimeter. Okay, so the length is given 0.2 millimeter, gap is provided. If the temperature of rod is increased by 200 degrees centigrade, 200 degrees centigrade, if you are increasing the temperature, what is the axial stress? Means thermal stress, longitudinal stress. Axial means along the longitudinal, or the longitudinal stress, or the thermal stress. Young's modulus is given, coefficient of thermal expansion is also given. Okay, that means alpha is given, delta t is given, length is given, lambda is also given. If you solve, you will get the answer. But now try to understand what is actually happening, how you will solve these kind of problems. So first of all, what you will calculate, the first of all, you will calculate the free expansion of rod. How much it can expand. How you will calculate the free expansion? Change in length is alpha delta t into L. Okay. When you are increasing the temperature, it will be expand alpha delta t into L. What is the alpha value? Alpha value is, what is the alpha value? Yeah, 10 to the power of minus 5. Delta t is 200. Yes. And the length is 250. If you calculate, you will get 0.5 mm. 0.5 mm. Okay, everyone please see on the screen. Free expansion rod means you increase the temperature. Don't bother about this support. You are increasing the temperature, it is expanding, but it is expanding 0.5 mm. But what is the elongation which is allowed? 0.2. That means 0.3 mm, the elongation, it is resisted by this support. What it means? When it is resisted by the support, that's why the resisting force is coming now. Then its thermal stress is developing. So I can say, what is the value of this one? Alpha delta TL you have calculated. This is the actual expansion. How much expansion is restricted? Expansion restricted is nothing but 0.5 minus 0.2, which is 0.3 mm. 0.3 mm. Okay. So now, if suppose you want to calculate the stress value, how you will calculate the stress? You know one more formula. Stress is E into strain value. Is the Young's modulus is given? Yes. 200 into 10 to the power of 3. What is the strain value? The strain value you can calculate whatever the expansion which is restricted divided by the total length. The total length is 0.3 into 250. Once you will solve, you will get the 240 megapascal. 240 megapascal. But what is the beauty of this question? The expansion which is restricted 0.3 mm, that's why the thermal stress is developing. No. For example, if you are allowing free expansion, the stress value will be 0. But you are only allowing the 0.2 mm expansion is provided. That means 0.2 expansion is allowed. How much expansion is restricted? 0.3. So that means it will touch here, then there will be a reaction will come. And this reaction, because of this reaction, you know, when the reaction is coming, now it will become the second case, which you know this particular formula. So the thermal stress, if you use alpha delta TL, you have calculated 0.5, this one. What is the lambda value? Lambda value is 0.2 divided by length is 250 into E. What is the E value? 200 into 200 gigapascal means 10 to the power of 3. Once you will solve, you will get 240 megapascal. What is the important thing is in this question? For example, if I have given the expansion, this expansion, suppose if this expansion, the allowed expansion, if I am given 0.6 mm, 0.6 mm. For example, I am framing the question. This is the rod, and this gap, instead of 0.2, if I am giving 0.6, can you tell me what will be the thermal stress in that case? What will be the thermal stress in that case? When I am allowing the 0.6 mm. Anyone? Jagan, Joshi, Raj, can you please tell me when
Sir,
instead of 0.2, yeah,
the stress will be 0.
correct. Very good. This is the main point. The answer should be 0. Why it is 0? Because 0.6 mm you are allowed. But how much you are elongation you are getting? 0.5. That means this portion is not touching the surface. How the reaction will come? If there is no contact, if there is no reaction, then there is no resisting force, stress value is 0. That's why I told you I will discuss this. The important condition is whenever these type of question is coming, first of all, you will calculate this delta L value, alpha delta T into L. If this expansion is more than the data which is given in the question, then the thermal stress will develop. You can use directly this relation. For example, if this expansion is less than the gap provided, then the stress value is 0 because this portion will not touch here. For example, 0.5 you are getting, I'm giving 0.6. What will happen? So let me take this diagram. So let us suppose this value is 0.6 mm and there is a rigid support. Now what you are increasing temperature, increasing, then it will go till 0.5 only. It will not come in contact here. There means there is no reaction. There is no reaction means thermal stress is 0. So this will behave as a free expansion case. So freely it is expanding. I hope you got this point. And this is very, very important. So in these type of problem, you have to first of all calculate delta L. If this delta L is greater than the gap provided, if this delta L is greater than the gap provided, use this one. If it is not provided, for example, this gap, this value is less than the gap value, that means it is not coming in contact with this surface, it is freely expanding, stress value is 0. Is this point is clear? Jagan already understood. What about Joshi? Please respond in the chat box.
Sir, here how free expansion of rod is taking place, sir? It is case 2, sir, not free expansion of rod, sir.
Janice also understood. What I have told you, when this expansion value is 0.5 you are getting, let us suppose if I am giving the 0.6 mm, in that case it will behave as a free expansion. Why? Because this point will not touch this one. Right now it is the second case. For example, if I will modify this question, suppose if this question is giving, if I am giving, this is the rod and this is the support and this portion I have given 0.6 mm. Now in this particular case, it will behave as a free expansion. Why? Because if you are increasing the temperature, the rod will expand till here only, 0.5. So this portion is not coming in contact. So this is not nothing but the free expansion only, no? It is not coming in contact. It is freely expanding. When there is a restriction, then it will become second case. Understood?
Okay, sir.
So you understood this part and this is very important. Now let's discuss some important relation. Okay, one more thing I want to discuss. So this very basic thing, change in length, that means the elongation, you know that alpha delta TL, alpha delta TL. What is the strain value? The strain is change in length by original length, which is alpha delta T. Okay, because you know that what is the strain? Change in length by original length. Just to divide this length here. So strain is nothing but alpha delta T. So if they want to calculate the strain value also, you can easily calculate. Just multiply alpha into delta T. Now, one more question, theoretical question. Read the question and tell me what will be the answer. Okay. So four options are given. First of all, read the question. This question you can easily solve if you understood whatever I have discussed till now. Please read the question, each and every keyword. Read the question and tell me if you got Okay, Janice has given the option C. Janice, can you tell me why option C is correct or option B and option A and option D is wrong? According to you, the option C is correct, you are telling. Can you explain why the option C is correct?
The thermal stress is zero because it is free to expand from one side.
Very good. This key point I want to listen from you. So if you read the question, that's why I've told you a circular rod of length L, area is A, has a modulus of elasticity is E, coefficient of thermal expansion is given. One end of the rod is fixed, other end is free. This is the only keyword. Other end is free means this is a free expansion case. In case of free expansion, what is the thermal stress value? Thermal stress value in case of free expansion is zero. In case of free expansion, the thermal stress value is zero. Then what about the strain value? The
So
strain
strain
value
value will be alpha delta T.
alpha into delta. Very simple. Okay. Now everyone knows the thermal stress formula is alpha delta T into A, and alpha delta T is the thermal strain. That's why they have framed the first option, this one, where the student will do the mistake. The stress developed in the rod is alpha delta T into E, but this is only when there is a resisting. When there is no resisting, the stress value will be zero. So the answer for this question is option C. I hope you understood this key point. Now the next thing is, Janice, can you mute yourself? Okay, thank you. Now the next thing is, again I'm telling you, read the question carefully and tell me what will be the answer.
0.
Sir, the answer of this question is option B, D, sir.
Jagan, answer 0 is correct. Again, you have to see the keyword. A steel cube with all faces are free to deform. Clearly mentioned, a cube is there, rectangle bar, whatever it is freely deforming and it is a free expansion case. If it is a free expansion case, what will be the thermal stress? 0 only, no? So the correct answer for this question is 0. That's why I am telling you, in every question, read the question carefully. The other end is free. Free means free expansion. All the surfaces of the cube are freely expanding. So the correct answer for this one is 0. But one more question is there that is related to the thermal stress only. How you will solve this problem? Actually, a cantilever beam is there, tubular section. That means it is consisting of two material, which is already given. Now, what you have to calculate? There are the four options given. You have to identify either the stress developed in the steel as well as copper, either in tension or compression, or there will be no stress. There will be no stress. How you will solve this problem? So for that, you have to see first whose alpha value is more. Whose alpha value is more. Okay, now please see on the screen. The question is, let us suppose there is a tubular section, means this is basically a question given. The cantilever beam of tubular section consisting of two material, copper as the outer. Okay, so this portion is basically the copper one. The outer portion is copper one. And inside, let us suppose the hollow copper tube is there. Inside, what you are doing? You are inserting one steel. Steel is the inner cylinder. This one is the steel. This one is the steel, and this one will be the copper. Okay. Now it is subjected to a temperature rise of 20 degrees centigrade. Now what you are doing? You are increasing the temperature of these composite bar or composite what we call as a rod. You are increasing the temperature by 20 degrees centigrade. And it is given that alpha of copper is greater than the alpha of steel. That means this alpha of copper is greater than the alpha of copper is greater than the alpha of steel. Now you have to identify the stress developed in the tube will be. What will be the stress developed in the tube? So if you understood this condition, no, then your problem will be solved. Now what is
Option A.
Option A? Let me check, Jagan.
Okay, sir.
Option A is correct. Okay, no problem. At least you have understood. One will be in tension, another will be in compression. So either option A is correct, option B is correct. So see, the alpha of copper value is more than alpha of steel. What is the first of all change in length? Can I write alpha delta T into L? Both having the same length. Delta T is also same. That means alpha is different. If alpha is different, if alpha value of copper value is more than the steel, what it means? Alpha value of copper is more than the steel means it will expand more. Yes or no? Are you agree? This alpha, let us suppose if I am taking this one, so let us suppose this copper is expanding this much, change in length of copper is this much. What about steel? Steel will only expand till here because alpha value of steel is less. So let us suppose this is the alpha of, delta L of steel. Now, if you know that both are in the parallel combination, that means one rod and the copper tube both are connected through a surface. So when you are increasing the temperature, then definitely they have the common deformation. Yes or no? It will expand equally because both are in the parallel combination. So can I write? Let us suppose the parallel, because of the parallel combination, let me take in the downward little bit. So alpha of copper is greater than the alpha of steel. So can I say this is the total composite deformation? So I will write here the total deformation of composite bar. Let us suppose I am denoting with the composite is CO. Okay. Now the total deformation will be at this point, which is in between this and this end point, because copper is expanding more, steel is expanding less, but it should expand at a same distance. So how you will get the same distance? Once you understood this part, then problem is solved. How you will reach here? Once you will apply the compressive force here or the compressive stress here, once you will apply the compressive force, or when you will increase the tensile load, then you will reach here, no? So in that case, whenever there is a composite bar or the parallel combination, one will be in the compression and another will be in tension. Which will be the compression? The alpha value, whose alpha value is more, that will be in the compression. Because alpha of copper is more, copper is more, what will happen? The copper will expand more, but because of the common deformation, you have to apply the compressive stress. So the reaction force will act here, which will be in the compressive. Now, what about the steel? Steel is expanding less as compared to copper. Let us suppose the expansion is here. So you have to apply the tensile force. So in that case, the tensile stress will develop in the steel. So in case of steel, tensile stress will develop in this case. I hope you got my point, Jagan, where you have done the mistake. So the correct answer for this question is B. Is it clear?
Okay, sir. Means
Understood?
okay,
Understood.
So please make a note of this. Whatever the alpha value is more, alpha value more means more it will expand. So if it is more expanding, but because of this parallel combination, you have to apply the compressive forces to get the uniform, what we call as a common change in the length. But for steel, it should be a tensile. So the correct answer for this question is B. Yeah. You are
okay,
telling?
sir. When heat is applied, steel will go to tensile stress and copper will go to compressive stress.
See, they have given the copper and steel. I can frame in any material. For example, if I will tell you, instead of steel, I will give you the brass. I will give you the some other material. But you have to know one condition, whose alpha value is more. If alpha value is more, always remember in parallel combination, if alpha value is more, it will expand more. That will be in compression. So copper having more alpha, so that's why it is in compressive mode. Got it?
Okay, sir. Means okay here means, sir, you are saying as per the question only. Means as per the according to question, alpha copper is greater than alpha steel.
Yeah. It is given only. Then if alpha copper is more than alpha steel, then alpha will expand more, no? What is the change in length?
Yeah.
Alpha delta T into L. Delta T is constant for both of them. Length is also same for steel and copper. So alpha is more means it will expand more, no?
Yes, sir.
So if alpha is expanding more, so that should be in compression because you want a common deformation. So steel will expand less because of the less value of alpha. So that you have to apply the tensile. So I'm giving one trick. If alpha is more, that means that will be in the compression. So whenever you see this type of question, if alpha value is more, just mention that will be in the compression only. Got it? Okay. So I hope you understood this concept. Now, one more question. It is basically related to the stress and strain diagram. So there are various points on the stress strain diagram. So you have to identify which one will be the correct. Okay. So they have framed one stress state diagram they have given for mild steel. So you have to identify which point belongs to which one. So first of all, can you please tell me what is this P point? Actually, what they have done, they have taken an enlarged image of this and they have mentioned some point here. P, Q, and R and S, and this is T and this is U. So you have to identify this P, Q, R, S, T, U belongs to which point. Do it fast. This is very simple. I think you have studied in your 11th class also, where there is a stress strain diagram, where you have studied the Hooke's law. Okay, now see, the first point is called as a proportionality limit, which is denoted with the P, where the stress strain diagram is linearly proportional. That means this proportionality limit where the Hooke's law is valid, that is stress is directly proportional to strain. This P point is the proportionality limit. So for P, there will be answer 3. Answer 3 means this will be wrong, this will be wrong. So either B is correct or C is correct. Now there is a Q point. Q point is called as the elastic limit. What is the elastic limit? So when you are increasing the load, the deformation will increase. When I'm talking about load means stress only, okay? Because load divided by area is the stress. When you are increasing the load, the deformation is increasing. So you will reach to another point which is called as the elastic point. When you will remove the load, it will regain its original shape. That's why it is called as the elastic point. Elasticity means when you are increasing load, it will elongate. When you remove the load, it will regain its original position. So Q point is nothing but elastic limit. So your answer C is the correct. Okay, so you can easily identify if you know the 2 points from this particular question, but I will explain other also. The R is called as the yield point. The R is called as the yield point where the deformation will going to be start. Then T is called as the ultimate tensile stress. Ultimate tensile stress means the maximum value of stress at which the material will can sustain. Suppose if there is a material, if you are increasing the stress value, so this is the only maximum stress it can sustain. Otherwise, if you increase beyond this, it will fail. And this U point is called as a fracture point. Okay, so P belongs to 3, which is proportionality limit. This point. Q belongs to elastic limit, which is 4. R is the yield point. Okay, then T belongs to, sorry, S belongs to, what is the S point? S point is the this one. One is the upper yield point and this is the lower yield point, because one is the point above, another is the point below. So S belongs to lower yield point. Then there will be a T point. T point is the ultimate tensile strength. That means T is 2 and U value is failure point. Okay, so you can see here 3, 4, then after that 3, 4, 1, 3, 4, 1, 5, 2, 6. So option C is the correct one. So one is the elastic point, one is the proportionality, elastic, upper yield point, lower yield point, ultimate tensile strength, and this is nothing but the fracture point. Okay. They have asked only one time this question, but this is very basic or straightforward. But I am expecting there are a lot of things are there, so they will never ask these kind of question. What is yield point? What is this ultimate tensile point? But they can ask regarding to this one. So if I will discuss one question, if you understood that particular graph, you can easily tell me in an engineering stress strain curve, whatever the stress strain curve which I have drawn for mild steel, what is the ultimate tensile strength? Just now I have discussed the definition and the same question they have framed in 2017. What will be the correct answer? What is the ultimate tensile strength? If you want, I can take the same figure here so that you can easy. See
Maximum
the diagram.
stress.
Very good. The ultimate tensile strength is nothing but the maximum stress. T point is nothing but ultimate tensile strength. You can see the maximum value of stress. So what is the correct answer for this question? C is the correct answer. Okay, so this question was asked in the GATE 2017. Now there are the two important relation between the what we call as a engineering strain and true strain. These same thing I have discussed in SOM also as well as in manufacturing. So just for remembering, I'm just giving you the relation. The true strain is nothing but ln of 1 plus engineering strain, ln of 1 plus engineering strain. And the second one is the true stress can be written as sigma naught, that is longitudinal stress, 1 plus engineering strain. Okay, so based on that, they are framing the question, these two important relation. So engineering strain means you can easily calculate what is the engineering strain, change in length by original length. Okay, if the change in length and original length is given, you will get this value. Once you know this value, just take the logarithmic value, you will get the true strain. Just 1 second. Let me charge this. Yeah. Now the true stress is sigma naught, which is the engineering stress only. If you want, I will use the same notation. Engineering stress is force per unit area, that is nothing but the resisting force, normal force per unit area. So that means if you know the engineering strain, you can calculate the true strain as well as the true stress. Because these part you can easily calculate once the load and area is given, you easily calculate this value. And the engineering strain also you can calculate. Okay, so based on that, they have asked one question. Can you please tell me what will be the answer for this question? So what is the question? Engineering strain of the material sample is given as 0.1 percentage. Okay, that is given in percentage. You have to calculate the true strain. The true strain relation you already know. The engineering strain which is given. Okay, so please tell me what will be the answer. Do it fast. Anyone got the answer? Very simple. No? The true strain you have to calculate logarithmic value of 1 plus engineering strain. What is engineering strain given? 0.1 percentage. That means 0.001. Once you will calculate, you will get the value 0.099 percentage. Okay, so the option C is the correct one. So one more question I can frame. For example, bar I am considering, and I'm applying the load 50 kilonewton. Okay, the area is also I am giving as, let us suppose, 300 millimeter. Okay, no need to solve, just understood. So what will be the, and the engineering strain I have given for this particular problem, you have to calculate the true stress. How you will calculate true stress? 1 plus engineering strain you already calculated, because one engineering strain is given, 1 plus engineering stress. How you will calculate engineering stress? Engineering stress, you already know, whatever the stress is nothing but engineering only. So load divided by area. Load is given, area is given, just divide and put here, you will get the true stress also. Okay, the true stress also you can calculate, true strain also you can easily calculate. One more conceptual question. So the stress strain diagram for two material, it is given. Okay, the material A and material B. So you have to identify, and regarding this figure, they have given the two important statements. And based on these two statements, they have made the four options. Okay, read the question, and if you know the concept, just let me know. Otherwise, I will explain. What is the question? The stress strain diagram for two material, it is given. The condition material A is more brittle than the more material B, and the ultimate tensile strength of B is more than the A. Okay, the ultimate tensile strength of B is more than the A, and A is brittle. Can you please tell me what is the difference between brittle and ductile material? Anyone? If you understood this thing, then yeah, tell
Brittle
me.
brittle material fails without yielding.
Very good. And any other things about the ductile? Okay, your answer is close to correct only. But one more points or one more comment you want to add? Brittle material, you told it will fail without giving any indication or the yielding. Okay. Okay. Now try to understood ductile material and the brittle material. So the ductile material means the material which undergo large deformation before the failure. Okay. So the previous diagram, if you also see this diagram, this is the ductile material diagram, which undergo this much deformation because this is the yielding point. No, yielding point means from where the deformation starts. This much deformation happened, then it will fail. So the ductile material are those material which undergo large deformation before failure. Large deformation before failure. But what about the brittle material? Brittle material are those material which doesn't have any yield point. It will fail without giving any indication. That means once you will reach here, it will directly fail. So can I say the material A, if you see, there is very less or small amount of deformation. But in case of material B, there is a large amount of deformation. Deformation means a strain value. The strain value, if you consider for the same amount of stress, this is only deformation for the material A. But for material B, if you see, this much amount of deformation is going on. So material B is deforming more. Can I say the material B is a ductile material? Yes or no? And the material A is a brittle material. This is first point. That means there is a very less or negligible plastic deformation. Negligible plastic deformation. Okay. That means before failure, it is basically having a very less deformation. Once you reach to the yield point, directly the ultimate tensile strength will come. There is no yield point in case of brittle material. But for ductile material, there will be some yield point, then it will undergo, there is a maximum stress, then it will fail. So now we understood the material A is more brittle than the material B. The option first will be the correct one. No, the second option, the second statement is the ultimate strength of B is more than A. What is the ultimate strength? Just now I have discussed. Ultimate strength means maximum value of stress. Can you see here? The maximum value of stress is here is this much, and the maximum value of stress for B is this much. So is this statement is correct? The ultimate strength of B is more than that of A. Can you please tell me? Is the second statement is correct or wrong? Anyone? The ultimate strength of material B is more than that of A. Yeah, Janice, tell me. Can you comment on the second statement? What is the ultimate strength? Ultimate strength is maximum value of stress. If you see the graph itself, no, you can easily identify. The stress value will be maximum for this one is this much, and this one for this much. So which having a more strength? Material A only, no? So material A having a more strength, that means this statement is wrong. The ultimate strength of material B is more than that of A. He is telling B is more than that of A, but A having more. So can I say the material A is brittle, material B is ductile. That is correct. The second statement is the ultimate tensile strength of A is greater than ultimate tensile strength of B. But here they are telling ultimate strength of B is more than that of A, which is wrong. So which option will be the correct? The option C is the correct. First is true, second is false. You have to identify out of these four options which one will be the correct. Clear? Okay. Same question. I have discussed more than 3 to 4. So I don't want to invest more time on this. Simple question. A steel rod of length diameter D fixed at both the ends. When you are increasing the delta T temperature, Young's modulus is given, coefficient of expansion is given, thermal stress. What is the thermal stress formula? You already know. Can you tell me which option will be the correct? I have discussed the numerical problem also and theoretical problem also. What will be the correct answer? Why you are taking this much time? Very simple question. No? What will be the thermal stress in the rod?
Sir, basically the formula of thermal stress in the rod is E alpha delta T, sir.
That is the correct answer. No? A steel rod of length L, diameter D, fixed at both ends. So this is the first case, no? When you are increasing the temperature, what is the thermal stress? Okay. Now, the next thing is question based on how you will calculate the bending moment. Okay, so one question is there, a concentrated load P, which is acting on a simply supported beam. What do we mean by simply supported beam? Simply supported beam means there will be two supports at the end. One is the hinge and another is the roller. Now, what is the question? P load which is acting on a simply supported beam at a distance of L by 3 from left support. L by 3 from left support means this is the load. Let us suppose P, this is L by 3. Now, what is this distance then? 2L by 3. Okay. So the bending moment at the point of application. So you have to calculate what is the bending moment at this point. Let us suppose this is A point, this is B point, this is C point. Yesterday also I have discussed some of the question, how the trusses also in which you have to calculate the reaction. I have told you in the SFD BMD also you have to calculate the reaction. You know this is a coplanar force condition. P force is acting. What will be the reaction at A and B? Do it fast. Tell me what will be the reaction at A and B? P force is acting. Just use the equilibrium equation. Summation of force in x direction 0, summation of force in y direction 0, and take the moment about any point will be 0. Let us suppose this is the hinge joint means there will be a two reaction, RA vertical and this will be RB vertical. What about this? RA horizontal. Just once again, RA horizontal. Can we say the horizontal force value will be 0 because there is no horizontal force? So only two reactions are there. This P force which is acting L by 3, can you please tell me what will be the reaction at A and B? Do it fast. Once you know the force value at A and B, you can calculate the moment because moment is nothing but force into perpendicular distance. Do it fast. I'm giving you only 1 minute. Use the equilibrium equation. Force in y direction 0 and moment about any point will be 0. You got the answer, Jagan, Janesh, Raj? You only have to calculate reaction. What is the reaction at A and B?
Calculating.
Do it fast. What about Jagan and Joshi? And did you got the reaction at A, Janesh? Very simple, no? Why you're taking this much time? The reaction at A, suppose if you are using summation of force in y direction 0, RBV, what is the total summation of force, which will be equal to P? Two vertical force is equal to P. Now, if you take the moment about A, how you will take? Okay, Janesh has given the answer. 2 RAP by 3. 2 RAP by 3. Okay, so 2P by 3 you are telling. Okay, RA value is 2P by 3. Very good. Correct answer. RA value is 2P by 3 means RB value will be P by 3. Very good. So this is the first equation. Second equation, you can take the moment about A is equal to 0. So P into L by 3. This is basically creating a moment in anti-clockwise. Clockwise. And this RB value is anti-clockwise. So can I write P into L by 3 minus RBV into L is equal to 0. So what is the value of RBV? RBV is nothing but P by 3. If you know RBV is P by 3, can I calculate RAV? Yes. P minus P by 3, which is equal to 2P by 3. So you know the value of RA is 2P by 3. So you want to calculate the moment at the C point. They have clearly mentioned the bending moment at the point of application of load. That means at C point. What is the bending moment at C? Force into perpendicular distance. What is the value of force? RAV. This will create a moment into this distance. So 2P by 3 into L by 3, which is nothing but 2PL by 9. 2PL by 9. 2PL by 9. So what is the correct answer for this question? Option. Is it clear? One more question. In GATE 2011, what they have asked, instead of point load, they have given the moment. Okay. Same condition you have to apply. A simply supported beam PQ is loaded by a moment of 1 kilonewton meter at the mid-span. The reaction RP and RQ you have to calculate. That means the reaction value at P as well as Q you have to calculate, and they have given the 4 options. Okay. Now what you will do, you will use the 3 equilibrium equation. Summation of force in x direction 0, summation of force in y direction 0, and summation of moment about any point will be 0. Let us suppose moment about P. This is a hinge joint. This is a roller support. Can I say, if I want to write down the reaction RPV vertical, RP horizontal, I'm just making as a 0. Why? Because there is no horizontal force. There is no horizontal force means automatically it will become 0. If you use the first equation, RPV is the only force which is equal to 0. Okay, so Janice, is this C you are giving for this answer or previous one? Janice has given the C as answer. Okay, let me check. Is it correct or not? Now, the moment value at P point, this I will mention as a, let us suppose R is given as 1 kilonewton meter. Okay, you have to calculate what is the reaction at P and Q. So here will be only one vertical reaction because of the roller support, RQ, vertical. So these two equations are there. You take the moment about P point, okay, and summation of force in Y direction, you will get the answer. I have already given the hint. Just try to solve. Use the equation 2 and 3, you will get the answer. And if you are getting the answer, please tell me what will be the correct answer for this.
Sir, in this question, sir, the horizontal reactions are not there or not, sir?
Can you repeat once again? What?
Sir, in this, sir, horizontal reactions are there or not?
Horizontal reaction will become zero, no? Because there is no
Okay.
horizontal force.
Option
Okay, sir.
one.
Yeah, Jagan.
Sir, in this question, in middle reaction with 1 kilonewton meters is acting, sir. A movement of such thing is there, sir. So if I take forces with respect to y direction, sir, this will be multiplied with half of the overall length of the beam.
You will multiply. This is already moment is given, no? This is not a force. Are you seeing the unit? This is Newton meter. Newton is the unit of force into meter already given. This is not a force. This is a torque.
Okay.
Sorry, this is a moment. Directly you can calculate the moment about P. This RQV into 1 is equal to 1.
Okay, sir. Instead of taking summation of vertical forces, I can directly go for this moment.
But one reaction you will get, no? How you will calculate the other reaction? You will calculate the other reaction by using summation of force in Y. Try. If you are not able, I will do. But this is very simple question. Yeah, Jagan, you are telling something?
Option A is the answer.
Option A will be the answer. Okay. Now see, summation of force in Y direction. What is the RPV plus RQV is equal to 0. Why it is 0? Because there is no vertical force. This is a movement. You can see the unit also, kilonewton meter. Okay, that means if you take the moment about P point, which is equal to 0, what is the force which is creating a moment? This is creating a moment, and this is already moment is given. Okay, so RQV into 1, which is in anti-clockwise, is equal to 1. So RQV is equal to 1, which is coming out to be positive. That means your direction assumed will be correct. So can I say from the first equation, what is the RPV? RPV is nothing but minus of RQV, and RQV is coming out to be 1. So this is minus 1 kilonewton. So that means this is acting upward, which is 1. So this is negative, means whatever the direction you assume, just reverse. So what is the correct answer for this question? RP value you are getting 1 kilonewton. Magnitude wise both are correct, but here it will act downward and here it will act upward. So what is the correct answer? A. Very good, Jagan. A is the correct answer. Only in every question you have to use 3 equations. Summation of force in x direction, summation of force in y direction, as well as moment. Okay, so one more question, little bit tricky. If you see this particular question, they have given the moment. Now one more question I'm discussing, they have given the uniformly distributed moment. Now you have to calculate what is the bending moment at midspan. That means at a distance of L by 2, you have to calculate. But methodology will be same. Again, you have to use the summation of force in y direction and moment about any point will be 0. How you will do? This is the beam. This is the beam. This is basically a support. Can I say this is RA and this will be RB? Vertical, and this is vertical. Again, Why I'm not considering horizontal reaction? Same thing. There is no horizontal force as in the previous case. There is no horizontal force. So automatically this value will be 0. So two reactions are there, but there is a uniformly distributed moment. There is no vertical force. Can I write summation of force in y direction will be 0? So what is the force in y direction? RAV plus RBV is equal to 0. Let us suppose this is the first equation. Now you have to calculate, you have to consider the moment. This is m kilonewton meter per unit length. But what is the total length of this beam? The total length of beam is L. So what will be the total moment? Total moment is m into L value. Yes or no? The total moment will be m into L, where it will at the center. It's just like a uniformly, for example, if there is a beam, if there is a uniformly distributed load whose intensity is given as W kilonewton per meter. If length is L, so what is the total load? W into L, which will act at the center, which is the vertical load. So here uniformly distributed moment is given. So the moment into length will be the total moment which will act at the center. So let us suppose m into L. Now if you take the moment about A point, summation of moment about A point is 0. How much you will get? This length is L. So can I write RBV into L is equal to m into L? So L will cancel out. LL will cancel out. How much you will get as a RB? So RB value you are getting as a M. So RB value if you are getting as a M, can I say RA is minus M? Minus M. So RA and RB you got, but what you have to calculate? You have to calculate what is the bending moment at C. Previous question and this question both are similar. The previous question they have given the concentrated moment, but now they have given the uniformly distributed moment. So how you will calculate? Again, bending moment, can I say at C point, let us suppose this is the C point. What will be the bending moment at C point? First of all, there will be a reaction which you got as a RAV, which is nothing but minus M. Okay. Suppose if you want to calculate from other manner also, you will get the same. Now see, this RAV you are getting as a minus M, which is nothing but a minus M. So can I calculate the bending moment here? So this minus is basically indicating whatever the direction which you assume that it will be reverse. Okay, so this moment is acting here m. So m into L by 2, m into L by 2. Now this is creating a moment in this direction. What about this moment? Now if I will consider this beam, the m into L by 2 is the net moment, because you want to calculate the moment at C point. So the total moment will be at center point for this beam will be m into L by 2. So can I calculate m into L by 2 minus m into L by 2 is equal to 0. Why I have considered this minus sign? Because this moment is creating a moment is anti-clockwise. This moment is creating a moment in the clockwise, which is nothing but 0. And this, for this question, the correct answer is A. That means in this particular question, what you have to do, again, you have to use the same three equilibrium equation. So there is a m uniformly distributed load. So the distributed load you can write in a single concentrated moment, which is m into length L, because it is distributed ml. So you have applied the two equilibrium equations, summation of force in y direction 0, Ra and Rb value will be 0. So Ra value, first of all, you will calculate the Rb value. How Rb value will calculate? Take the moment about A point is 0. What are the force which is creating a moment? RBV into L, RBV into L, anti-clockwise, M into L, clockwise. So RB value you got as a M. Once the RB value is M, so RA value is minus of RB, which is nothing but minus M. What is this minus sign is indicating? Downward. Same thing I have done here now. If you are getting as a minus, so RP value is acting downward. So same here, if the reaction you have calculated M value, so this is M into L by 2 is the moment. Now for this particular portion, what is the net moment? This is M and this total length is L by 2, because you want to calculate at C. So M into L by 2, you will get the 0. Is it clear?